Hi everyone. Welcome to the very first video of Code and Clarity. Today, we will be discussing about the linear search and the binary search, that is the different search strategies. Now, this two type of search is a very important topic in case of data structure and algorithms as well as any other computer science topic. So, without any further delay, let's delve into the topic that is the search strategies, the comparison, the algorithms of the linear search and the binary search. Now, linear search. So basically, at first, we need to know what is a search. Suppose if you cannot find an object, you search it and find it as simple as that. So in case of linear search also, linear search is basically a sequential algorithm that checks each element in a list or an array one by one until the target element is found or the end of the list is reached. So here, let's consider a real life example. Now, suppose there is a long queue of people and you want to find the person who is wearing green specs. What you can do? You can either begin from the starting, that is the beginning of the queue, or the end of the queue. From starting from either side, you can just move to each and every person standing in the queue and check whether that person is wearing specs or not. So likewise, you will be finding the person who is wearing the specs. Here you move in this image which is given. You moved to the first person and check whether the person is wearing specs or not. He is not. You move to the second person and check whether he is wearing specs or not. He is not wearing. Then you move to the third person and he is wearing the specs, and you have found out the person in the queue who is wearing the specs. So, as simple as that, linear search is nothing more difficult. So, here next we will be discussing the algorithm. So, before that, I am showing you an example given using the array which is given here. Like here we have the array. So 0, 1, 2, 3, these are the index of the array, and 1, 6, 5, 7 are the elements. Now we have a key element. This key which is needed to be found. So what is the key element here? Here it is the 5 which we want to find. So what we can do in case of the linear search? We move to the zeroth index, then we check whether the element in it is 5 or not. It is 1, not 5. So we move to the next element. If it's, we will check if it's 5 or not. No, it's a 6. We move to the next element, that is the second index. Then we found out that yes, this is the element. So 5 is the required element. So here I have written the algorithm. Please check the algorithm and take screenshot or write it down. Next, we'll be moving to the binary search. So, linear search is a basic algorithm. There is nothing strategic in it. So, we need a much more strategic move or much more efficient in terms of space complexity and time complexity. So, we invented the binary search. What is the binary search? Binary search is an efficient algorithm that finds out the position of the target value within a sorted array by repeatedly dividing the search interval in half. It is complicated. Let me explain in simple terms again. Suppose you have a dictionary. So, how do you find a particular word in a dictionary? What you can do is you can divide the dictionary into exactly two equal halves and find out the middle part of the dictionary. Now, suppose the key element is I. You want to find any word starting with I. So, you moved to the middle of the dictionary and checked that whatever is present in that middle, I is before that or after that. If I is before that particular element, then you check in the left half of the dictionary. And if I is after that, then you check the right half of the dictionary. So then, likewise, again, you will find out the middle part from the left subarray and then check whether I is in which part. Like in this way, one you will ultimately find or reach up to the element or the required number. So, so here I have again given the explanation with an array. So here we have an array 0, 1, 2, 3, and the elements which are present are 1, 2, 5, and 7. So we want to find 1. So how we will find 1? In using the binary search, we will just divide the array into two equal halves and find the mid. How do we find the mid value or the median value? Low plus high by 2. That is low index plus high index divided by 2. So what is the low index? Here 0 is the low index, high is 3. So 0 plus 3 by 2, it returns 1.5. We will discard the fractional part 1. So we will check the first index, that is the value of the mid of the array. So what is present here? It is 2. So this 2 value is the mid. And what you want to find? We want to find 1. So 1 is less than 2 or greater than 2. Less than 2. So we will check the left subarray. So here we don't need to check further. We have found the element 1. But if we had not found 1, then we would have divided again the left subarray into two equal halves, retrieve the value of mid, then again tally the value of the mid with the value with the key given, and likewise we will find out the ultimate element. So one thing to keep in mind is, in case of binary search, we always need to take a sorted array. This we need to keep in mind always. So here we have the algorithm. Select the middle item in the array and compare it with the key value to be searched. If it is matched, then return the position of the median. If it does not match the key value, check if the key value is greater than or less than the median value. If the key is greater, perform the search in the right subarray. But if the key is lower than the median value, perform the search in the left subarray. Repeat the steps 1, 2, and 3 iteratively until the size of the subarray becomes 1. If the key does not exist in the array, then the algorithm returns an unsuccessful search. So this is the algorithm explanation of the linear search and the binary search, and we will move on to the comparison and which one is better. So before that, this is the very first video of my channel. Please like the video, comment how do you like this video, what difficulties you had in understanding it. I'll be explaining in the comments too. And subscribe to my channel, share the video so that I can bring much more fruitful content to you, much more easier explanations to you. I can, and also let me know in the comment sections what topic you want the next video on. Like I can teach you DSA, I can teach you any other computer science subjects, maybe object oriented programming, computer networks or operating systems, anything. I can also teach you Java. Then I can give you placement preparation. I can teach you aptitude. I can teach you web development. So anything on what topic you want my next video should be, please let me know in the comments, and please share the video so that I can mm, get encouragement and enthusiasm to make more such videos. Now let's switch to the comparisons. Linear search and binary search. So in case of the linear search, the differentiations, okay. In linear search, the input, these are actually very much basic. In linear search, the input data needs to be in sorted order, but in case of the binary search, the input data, no, sorry. In linear search, the input data need not to be in sorted order, but in case of the binary search, the input data needs to be in sorted order. It is called as a sequential search. It is called as the half interval search. The time complexity of the linear search is order of n. The time complexity of the binary search is order of log n. So the linear search performs equality comparisons, and the binary search performs ordering comparisons. Linear search is less complex. Binary search is more complex. Linear search is a very slow process. Binary search is a very fast process. Listen, since we are moving to each and every element in the array, in case of the linear search, so we are taking linear order of time. But in case of binary search, we are just dividing it into two halves, so the time complexity is getting much more reduced. Now this time complexity and space complexity, these are very vast topic. So if you want me to make videos on, so I'll be making a separate video series. Please let me know in the comments on this time complexity and space complexity. And linear search does not need any sorted array, but binary search needs the array to be sorted. Okay. And see, so we can easily find derive which one is better. So if you have ample amount of time, no constraints on space, you do not want to perform unique, so then you can choose linear search. But if you have time constraints, you want to make your solution much more unique and strategic, much more efficient, then obviously go for binary search, because binary search is much more strategic But one thing always keep in mind, you need to make the array sorted at first. If it's sorted, then well and good. If it's not, then sort the array, then perform the required search. Okay. This is the strategy, basic strategy. And in case of linear search, you do not need any sorted input. So this is all about the comparisons between linear search and binary search. Thank you for your support. Please subscribe to my channel, press the bell icon, like the video, comment, let me know on what topic I'll make the next video. Thank you.